Yeah, this is a presentation on a lab that I recently built to illustrate the skill sets that I have in my arsenal, as it were. So basically, this is quite a long video, so this has been broken up into chapters. So obviously the first chapter is just an overview of the lab. Second chapter is the architecture that I'm using. The third illustrates issues that I had with getting through to every single device and avoiding asynchronous routing, so I'm using a firewall. I'll go through that. The next part is the actual core itself, the MPLS core with the P and PE components. That will include description of the SRX that I'm using along with the security profile. Chapter 5 is about the AAA protocols that I'm using, TACACS and Radius, just a brief description of both and what the differences are. The last part is the use cases on the specific customers that I'm using in this demonstration. I'm using 3, I'll go through that later, and the last one is on the secure access into the lab from the internet. Yeah, in this presentation I'm playing the role of a service provider that offers the following service to my customers. A private MPLS VPN delivery with the presence in all major centres. Secure data centre managed services where customers can purchase managed applications housed in this particular case at the service provider's central premises. In this scenario, there are 3 separate customers set up. Customer A, who's a travel company, customer B, who's a musical instrument provider and accessories reseller, and a lighting retailer who has presence at all these customers has presence at every single site. Now here's a basic setup of the topology of the network. Inside the circle you've got the MPLS core, which are the 3 Cisco routers, and on the edge of each one of those routers is a PE, which is the SRX, Juniper SRX firewalls, but they can act like routers. In this particular case, I'm getting them to do both. At each of the SRXs, you can see that I'm terminating VRFs on each one. So on the F5 facing PE, you can see in green, I've got 3 instances there. They've all got the same AS number, but appended with 21, 22 and 23 to represent customer A, customer B and customer C. On the other one in orange, same thing, and with the other one in blue, the same thing. Here's the hardware that I'm actually using to stimulate this entire network. I've got 2 ESX servers. They're both really old, over 10 years. All this equipment's about 10 years old. I've got DL360s and DL380 and a desktop PC that's running GNS to represent my core. And I've got 3 3550 switches to do the LAN part, and I've got a laptop on the left doing the DNS. The device on the right is just for this presentation. That's all it's doing, is recording this presentation. Yeah, to run the core, I run this through an application called GNS3. It's a freebie app, it's available on the internet, and it's a very good for doing stuff like proof of concept, sort of design work before you apply anything to a production network. Effectively, it's a GUI that allows you to open up, put routers into a scenario, connect them up together, and then set them up, and then you actually use real operating systems on them, so real Cisco iOS on them, and they behave like real routers. Obviously they're slower. I mean, GNS3 is an excellent application that runs both on Windows and Linux, but it's really resource intensive, and it really requires a really beefy machine when you're running it. especially on Windows, because the Windows GUI itself imposes a large overhead, and then you're effectively running a GUI over the top of a GUI. So, and I don't have the luxury of a top-end machine. For that reason, I run GNS on a machine that's running on a Linux kernel. So in this particular case, I'm running it on CentOS. In addition to the simulation using the GUI, I use the GUI to select the devices and build the topology, but that's the only extent which I use the GUI. Once I've put my routers in and connected them together, and in this particular case connected them to the outside, that's the clouds that you can see on each one of these. That's effectively a physical interface on the host that's running GNS. So basically what I do then is I just log onto the routers initially, put an IP address on the interfaces so that I can reach them, and then that's the extent of the use of this GUI. I then effectively turn the GUI off and then shut it down, and then I run it from the command line from then on. So I'm just going to close this down, and now I'm going to be running this from the command line. So now I have the routers available, I have that topology available to me, and then I just fire up the Dynamips, because it uses Dynamips to simulate the iOS, the routers themselves. So I fire up Dynamips, and then what happens then, I then run the actual topology itself using Dynagen. So it's a sort of three-stage process. First, I use the GUI, build my topology, just make sure I can get access to the routers when I turn the GUI off, and then run the whole thing from the CLI. And effectively, you can use I mean, this machine that I'm using is it's just a PC Pentium P4 desktop machine, effectively. So it hasn't got a great deal of RAM on it. Hasn't, I paid $100 for it, and I can run quite large networks using GNS3 through the command line. I mean, so it's a little bit slow. All of these machines, obviously, when I'm running all this stuff up, I've got like 25 machines I'm running on physically on 3 physical machines. So it's not going to be super fast, but if it gets to be a problem, I will actually turn off hosts that I've got running that are not relevant to the particular sections I'm running. So here are my 3 routers now. They're running, being simulated now in GNS3. So as you can see, they're all running. They're all actively running now. I can reach them actually from this host if I do a telnet from this host to 127.0.0.1 on port 2000. I think it's port 2000, 2003, 2008. So there you go. On to the next section. This is the first of my ESX servers that I use. Obviously, I've got, like I said before, I've got 2. This is the first one. It's the most important. It runs. This is on the DL380, and it runs ESX 5.1. This server is extremely heavily loaded. It's got somewhere in the region of 16 to 18 hosts on them. So it's a very busy box. When it first starts up, it doesn't start up all the hosts at once. I've only got it started a few because obviously I don't want it. I want to be able to get to the resources to have a reasonable level of performance. Obviously, as I start putting more on, it gets more and more loaded. The important ones here are effectively the F5 server, which is the one at the top, the Radius server, obviously, and every single one of these hosts are more than dual home. They've got more than one interface on them. They've got a management interface, and they've got, in the case of the Radius, it's got several because it actually communicates with a lot of the devices because of Radius and TACACS. It also accesses DHCP. As you can see, this device, this ESX host, the ESX server has only got 8 gig of RAM. The networks are really heavily utilized. As you can see, every single NIC has got a multitude of VLANs associated with it, and they're all heavily utilized. I found that I didn't have enough. This server's got 6 NICs in it, but that wasn't enough. I needed even more. So some of these ones you'll see have no adapters, and that is because I'm using the internal VM networks as well in order to be able to satisfy the requirements of this large network. So yeah, so it's a very busy box. The first host is basically pretty important. It's the F5. I'll just run through that now. Effectively, the F5 is protecting each customer resource, and in this particular case, the resource themselves are the customer web servers. As you can see, I'm using 4 physical. That's the maximum you can get on this particular. It's a demonstration model, so it gives you 3 interfaces plus a management interface, and each one of those are being used. So I'm logging on it now, and basically the F5, you notice on the ESX that I've only got a small number of devices that are actually running. So when I actually get onto the F5, which hopefully shouldn't be too long, the F5 will, obviously the virtual servers or VIPs will be, most of them will be red, because they're obviously not, each one of the devices themselves won't be responding because it's not on. So just log on now. Okay, so if I go to the VIPs, so, and as you can see, most of them are off. Now the top VIPs here are the customer web servers. Now, the customer web servers are basically just the small footprint Unix boxes with a web application running on them, and they are virtual hosted, one for the public facing interface and the one for the private. So if I go back, so as you can see, the radius one is obviously the only one that's running, so it's one in green. As I start turning them on, they will actually they'll all go green. This is the second ESX server that I'm running, which is the DL360. This is not such a powerful box. It hasn't got much RAM on it, so I'm only hosting a few machines on this particular box, and obviously when they're not being used I will just turn them off. But it's got a Windows server on there, and it's got some customer Linux servers on there. Each one of these Linux servers is a CentOS box, and I'll leave them off for now. I'll just leave the Windows one on. Like I said before, I'll just turn them on when they're needed. Like I said, this memory is only effectively 2 gig of memory available on this. It's a pretty slow machine. Networks, as before, you know, each one of the interfaces uses multiple VLANs. So I'm making the most out of these boxes. Pretty much, I can't do much more with them. So that's those. Now the Linux firewall, like I said before, this is actually responsible for making sure that I've got management separation. I have a management presence. Like I said, most of these devices are dual homed, and you can see a management IP address, and you can see a second address, which is obviously routes in through to the MPLS core. Because the management address is actually visible on both sides, I don't want to have asynchronous routing happening where a management address can be seen and can go through the core. Otherwise I'd have issues with routing. So what I've done here is the firewall, which you can see, which is indicated in red at the top there, it actually makes sure, it actually doesn't advertise the management address at all. So it's effectively masquerading, or it's using port address translation effectively to hide the management address away from the inside network. So I'll jump on the firewall and show you how that's done. So effectively I'm using the Linux firewall out of the box, which is, it uses IP tables. I don't know if people are familiar with IP tables, but it's a very, very powerful, it's very configurable, very hard to sort of get your head around it. It uses the concept of tables and chains, but once you get used to it, it's actually a very, very powerful firewall indeed. I'm using, as you can see, the configuration here. I'm filtering on the forwarding table and effectively picking. I actually don't need to filter on the forwarding table because I'm masquerading the output. So if I could just simply just let it all through, and because the masquerade is effectively port address translation, users can't get back through there. The TCP session has to be established from the inside out, so nobody can come from the outside in. But yeah, so that's effectively hides the management IP address away from the core, from the F5 side of this MPLS network, so you can't effectively see the management network from. You can only effectively get to it from the management IP addresses on each of the hosts on the edge. I was going to show you this on the DNS, but it's much easier to show you this on the SRX because it has additional capability. So I'm just logging on to the SRX, and I'm just going to ping the interface, management interface that I'm coming in on, 192.168.1.1. And as you can see, I'm getting no response, which is what I'm expecting to see, because obviously because of the masquerading, the port translation that's being done on the outside interface. When I go and have a look at the routing table, don't forget this is a VRF, so it's on the F5 shared VRF. You can see that the network's there, 192.168.1 network's there, going via the external interface, the firewall 10.100.100.254. So what I need to do now is to ping the interface and make sure I can reach it, and which I can. So that's pretty much, I can reach the external firewall, but obviously I cannot reach the 192.168.1.0 network, which is what we want to see. So the next thing now is to actually go to the one good thing about the SRX is that they have a shell, because they're basically run on FreeBSD. So I can actually log onto the shell and run typical stuff that you see on Linux. And one of the important tools there is TCP dump. I don't really need to worry about, because I'm coming in via the management, I've actually logged on to this SRX firewall, so I don't really need to actually look for any particular protocols. I just need to run a quick dump. I should be able to see all the shell traffic that are actually coming through, because I'm running a SSH shell. Anyway, as you can see, it's a shell session, but it's not coming from 192.168.1.1. It's actually coming from my external interface of my firewall, which is exactly what the firewall is supposed to do. It's supposed to masquerade my real IP address and use its external IP address and use port address translation, which is exactly what it's doing. So fantastic, it's actually doing what we want it to do. So there we have it. So effectively my management network is actually being hidden away from the core network, for the core MPLS network, by this firewall. And so I mean, I don't really need to have that 192 network in the F5, in the SRX at all, because it doesn't need to see it. Just to go back to the P routers, like I said before, these are Cisco routers that are actually running as an instance inside the GNS3 off the desktop we was looking at earlier on. The P routers themselves have a very small routing table. They only really effectively only need to know about where the PEs are. So the only routing that's going on is so that each one of them can get to the loopbacks of the PEs so that they can establish BGP sessions. So it looks very small inside there, and we'll be taking a look at that in the AAA stuff that we'll be doing shortly. For further information about MPLS, there's a video that I put out previously on YouTube. Again, these are the PE routers, which are the SRX firewalls, which are actually being configured using their routing components. The Juniper series, they have like a base sort of component, which is like the routing component, and anything additional on top, like the firewalls and that, are just added as extra features. So you can use the SRXs as almost like a full-featured router. And in this particular case, I am using the VRF features along with the security features, which we'll be touching on again a little bit later on when we're doing the customer use cases. This is an issue that has come up obviously as the lab builders come through. Like I said before, we're using VRFs on the SRXs for customer separation, which is great and it works really good. But there is a bit of a problem in this particular case. I'm using all three customers are using a shared F5 network. That's been done deliberately because I want to showcase some of the F5 stuff that you can do for website separation. So you can see here that I've got the routing table for one of the customers. I've got the 5 network, which comes from the F5 instance SRX. I've got the 101 network, which is site 1 for this customer, and I've got the 111 network, which is site 2. We're sitting on site 1, so you can see that 192.168.101 is a direct connection. Now on to customer B. Customer B looks very, very similar to customer A, with a small exception. Well, it's not a small exception. Customer B, if you look on the right hand side, there's another router that's actually connected to the SRX. This would be a normal scenario. I mean, and that router is actually a CE. And all your customers would effectively have their own router with maybe lots and lots of networks behind it. In our particular case, we've been using the SRX's direct connections on their interfaces, but this is a more realistic scenario with another router. So you'll see a network there, 11.11.11.0/30. That's the point-to-point connection to that CE router. So that would be, obviously that's quite important. You can see obviously those other routes are behind that. So, so that's the only exception to this particular case with this particular customer. They have their other routes as well. They have their default route, obviously going to the F5 SRX with the 10.100 network, plus their other peer networks as well. So they are actually, so that's the only difference, is this other route. So the other ones look effectively the same as the other ones, so with the exception of that point-to-point network, which is effectively what most of the customers would have anyway. Okay, so customer C is pretty much a very similar scenario to customer A, customer B. Obviously customer C addresses would be obviously the ones that you'll be able to see here. The important thing is here that you cannot see the other customer addresses. You can the addresses that are common to all of them is the default route, obviously 0.0.0.0, and the F5 shared net, which is 10.100.100. 128/25. but none of the other ones are there. Now jumping on the site 2 will give you pretty much the same sort of tables. Obviously the local ones will be the direct connection. So with this particular case with customer A, they're all pretty much the same, look exactly the same as what you would have seen when on site 1, except obviously the local one will be the direct connection. So there's no real difference between them. They, like I said before, they all see the default route. They all see the core F5 route, and they all see their own individual routes associated with them. So basically it's almost like a carbon copy of site A, but the only difference is obviously site 1. The only difference is that site 2 addresses are in play here instead of site 1. So and again, they cannot see each other. They can only see their own, effectively their own VRF routes. So I'm just going through it now, but it's pretty much self-explanatory. Like with customer B, obviously again we've got this 111 network. So they're all the same. So I don't want to rush, sort of go through it in detail. Okay, so now here is where the issue arises. So each customer has got access to a default route that points to this F5 SRX. Now, I'm jumping on the SRX now and looking at the routing table for the F5 shared network. It has the routes of each of the customer. The customer routes are leaked into this VRF, and the default and the 10.100.100 network is leaked from this VRF into each customer. So this guy has got literally visibility of all the customers. So obviously you can see all the routes. First of all, it's advertising its own, obviously, and then it's receiving routes by BGP from all these other customers. So the issue is here, as you can see, all these networks, you know, like the customer A1 is visible. I mean, they're all literally visible. So when we actually jump onto one of the customer sites and ping, so in this particular case, if I use customer A and ping the other site, customer A, for instance, then I'm going to get a response, a predicted response the way I want it to. And you'll notice that if you look at the ping times, this is a really important thing, like around about millisecond response time. Now I go to customer B and go and ping a customer B site. So again, the same thing, customer B can reach customer B, there's no issues there. Now here's where it gets interesting. Now if I try from customer B to go to customer C, I shouldn't be able to get to him, but I can. Notice the response time like almost doubled, and that's because it's going back to the core, and then from the core, because the customer C is visible, through from there. Here we do it again. So let's take, for example, let's say customer A. So we go from a customer A and we try to hit a customer B site. Again, it's successful. Look at the ping responses again. And yeah, exactly the same as before, and the same with C. I mean, they're all going to be exactly the same. Like I said before, they've got visibility to each other indirectly through the core because of the default route. So we got a problem here. So what's needed here is we need to filter these out. Now, in reality, you wouldn't do it this way at all. You'd actually, the default route would be going by their own VRF. But because the stuff that I want to do on the F5, which is best served when I have them running on a shared network, that's the reason why we've got to do that. So in order to get around this, we need to be able to filter them out. Now, it's common practice to filter everything at the core. You don't want nothing being filtered at the core, there's no point in actually sending a packet down to the core only to be rejected at the core. So you do all this filtering basically at the source. And there's two ways that we can do this. Well, two ways that I know that we can do this anyway. That is via route filtering, or zone filtering I mean, or we use null routes. Zone filtering is good, that's like using the firewall, but to be honest with you, it's much simpler using null routes. And for the purpose of this demonstration, I will be stopping the packets from getting through by actually putting all the other customer networks to null. Okay, so I've now gone onto all the devices and applied the filtering using the null route, and just going to now demonstrate by pinging. Well, first of all, we'll start with obviously make sure that the customer A's sites, 2 customer A sites, can still be reached. So just ping the first one. So, no, it's not coming on. The F5 instances won't be there because I didn't have enough devices to stick behind it, so I've left those interfaces shut down. But if I go to the other ones, you can see, you know, 111, 101, that I can still reach them, so that's cool, that's what I want to do. So now if I try to go to some of the other sites like customer B, obviously I can't reach it, and obviously 112 doesn't work either, and if I try the customer C, we'll have the same issue. So basically I'm not able to reach any of those these devices. So so pretty much it's doing exactly what I want it to do now. So obviously going through customer B's network, I'm able to reach the devices, and obviously it's pretty self-explanatory. I'm not going to be able to get to any of the other ones now, so it's pretty much doing exactly what I want to do. So so now that that's fixed, the next stuff I'm actually going to be concentrating on is the AAA functionality, and in that one you'll get to see some of the stuff on the P routers and what they can see. But as you can see, this is quite clearly doing its job now, so I'll stop it from that point. So this is the section on AAA that I've got running on the Radius server. Basically it's got Radius and TACACS, but we're looking at Radius first. So I'm just going to jump on one of the boxes. It's protected by Radius, the Radius component. And I've got 2 users set up, both at Radius and TACACS. One's called Mikev, which is an admin user. And as you can see, if I look at the privilege level, I've been dropped into level 15. And I can do all the sort of stuff that the level 15 privileged user can do, like showing the routing tables, and we're sort of looking at all the sort of different things. I mean, this is basically a switch, so we're running all switch commands at the moment. But so, and you know, it's pretty much, I can do everything. Like I said, I'm an admin user, so it's just been set up for that particular reason. So so yeah, so that's pretty much everything that you see if you've got a privileged user account. So I'm able to do a show tech and show ver. So now I'm going to log off, and I'm going to log back into the system again, and I'm going to log on as Bob. And as you can see, Bob will be a low privileged user. So if I try and do stuff like show run or conf t, or any of the sort of commands, you know, like that, it's spell it right, yeah. So you can see I can see all the routes, and pretty much some of the other stuff is, will work okay, but some of them won't, obviously, because he's a lower privileged user, Bob. So there are certain things he's going to be able to do, and there's other things, obviously, that he's not going to be able to do. So yeah. One of the problems I've got with Bob is that Bob has the ability to do some things that maybe I don't want him to do. Like, for instance, he has got the ability to do a show tech, for instance, and that's one of the things that I might not want him to be able to do. Now, and in addition to that, Radius is it's got a clear text protocol, and that's again has got issues associated with security and stuff like that. So there might be situations in a more secure environment where you won't want to use Radius, but want to use more of the flexibility of TACACS, and that's what we'll be showing next. Yeah, I was actually going to jump straight into the TACACS, but when I looked at the router, I didn't have any TACACS configuration, somehow I'd lost it, so I thought I'd better just get it put back in. So, I've just logged on as a TACACS user, MICF again as administrative privileges, so I just jump on and can do all the usual stuff. Just as a side note, just showing you the routing tables. I'm on the core router, I'm on a P router, and you'll notice that the routing tables don't have any customer routes in. It's no 192.168.101 network, or 102, or 103, or 111, or 113. That's because the P router doesn't need to know about those routes. It doesn't need to have. It doesn't want them. You imagine in a real life scenario with a service provider that's got thousands of routes. He doesn't want to know about those thousands of customer routes. That would be clogging up his routing table. It only needs to know about the PE routers and how to get to them. So that's the reason why there's no routes in there. So, so that's just a side note. But as we go on, like I said before, we've got all these all the usual commands that I can use to get in. So so all the stuff that's really important is there. Yeah, so like I said before, all the standard commands as you'd expect. Obviously, one of the most important commands there will be a show tech, in case you need to actually send anything off to the Cisco guys. And like I said before, you can go into configuration mode, and yeah, so it's here, like the privilege level, like I said, is 15. So yeah, so that's basically your bog standard stuff. Now we log back in. Now instead of obviously McCaff, we're going in as Bob, who's a low privilege user. And Bob has got very restricted access to what he can get to and what he can't get to. As you can see now, some of the commands that he's using he can't get to. He's got command authorization. That's because TACACS is very flexible about the commands that he can use. So basically he's got the same privilege level as before. So if he's a privilege level 7, he would still be on the same privilege, but the TACACS configuration can be done in such a way that you can say, okay, he's privilege 7 users, but he can also not have access to these commands. So you can be really, really granular about what Bob can and what Bob cannot do. You might find a situation where Bob needs to be able to do stuff in a high privilege mode, but if you give him that high privilege mode, he's got access to commands that you really don't want him to use. So you can give him the access, but then you can restrict his command sets, which is it's a very good thing. I mean, one of the things you might have noticed was that I was telnetting onto these boxes. Unfortunately, I haven't got a security image, so I couldn't create RSA keys for crypto. Normally, you really wouldn't want to do that for security purposes. You want to be running SSH. And now we finally move on to the use cases. There are three, one for each customer, and the prerequisites to this use cases are as follows. Just a prerequisite to the prerequisite, as it were. The management network will be able to reach every single website, every customer website, public and private, and the ISP website, public and private, without requiring credentials. So they have full access. We're just making the assumption here that the ISP is looking after the customer website, so they have full access. With that in mind, the following prerequisites are required. So the ISP is a management device in the customer A site on 192.168.101.15 that they're able to access using SSH. They won't be able to access any other devices in customer A. As in customer B, 192.168.112.15 can also be accessed by SSH. And again, no other devices in customer B will be able to be accessed. The F5 shared network will not be able to reach any customer devices. So that means anything on the F5 and that will not be able to initiate connections towards any of the customer sites. The exception, of course, is DNS, which obviously the customers are using for name resolution. So DNS traffic will be able to get back to the customers. Like I said before, the management will not be able to access any other customer devices except for those devices that they've been instructed to be able to get to, and the ping protocol. And as I've already mentioned earlier, the management network will be able to access all customer websites, public and private, without requiring credentials. And we'll be able to log on to the back-end servers using SSH. So they will be able to get through the F5 on both web and SSH traffic to the web service for the customer site. Now moving on to the use cases in detail. With customer A site users will be able to connect to each other on any other site within its own domain and using the following protocols: SSH, HTTP, HTTPS, RDP and ping. In addition, customer A users will be able to get to the customer A private site upon credential verification. They'll be able to access, they'll be able to reach their own public website, and they'll be able to reach all the other customer public websites. All these users as well will be able to have access to the internet. Now to start off, I'm going to show you the first of these prerequisites, which was actually access from the management network. So I'm now sitting on a management machine and I'm going to get access to every one of these sites. So basically what I'm going to do is start off with the customer A intranet site. With each customer, I've actually created a certificate for them specifically. That was done through the DNS server, the little laptop I've got. So they've all got their own certificates. So as you can see now, I can get onto the customer A intranet site. I went straight through, had no issues at all. So like I said before, the prerequisites of this was that the actual the management network can get to every single site unhindered. So if I do the same thing now with the website, you'll see that the same thing happens. It goes straight through, no problem at all. So that's the customer A public website, the travel company's website. So I'm going to do the same thing again now with the customer B website. So jumping on again to the customer B intranet site. Once again, I'll go straight through. No issues there at all. Now I'm going to do the same thing with the public site. So again, jumping on the public site. Gives you the... It's going to be running a little bit slow, unfortunately, as well, because I've got a lot of machines running. So you'll have to bear with the slowness a little bit. So there's the public B website. And the same now if I jump onto the internet site of the customer C site. Excuse my typing. And there we go. And they've got customer C website as well. Like I said before, it's a lighting company, it's lights and stuff. These basically are not really active, they're just passive web pages. It's just used as demonstration, just to show you demonstrate I can connect things through. So there we go. So we've got the customer A, we've got the customer B, and we've got the customer C websites. So what I'm doing now is I'm logging onto this site A, SRX, to view the policies that were defined for customer A. So primarily, you can think of these as an ACL from an ASA. So they're effectively access lists, and their policies are actually defined to the instance themselves. So we'll take a look at the policies for this guy. So here's what's been associated with customer A. Now the first part, just let me adjust this. The first part is addresses the issue that we had with cross-site routing. So customer A now is only going to be able to see customer A sites with this particular filter defined. All the rest are like standard filters that we're doing in order to accommodate the policy for customer A. So it's pretty much straightforward. If you understand ASA access lists, you'll understand this. Just the format's a little different, that's all. So we jump onto the Windows box on at site 1 for customer A. So it's pretty much a straightforward standard Windows box. Its position in the map is as follows. Looking at the map, you see all the customer A sites marked in red. The associated website on the F5 marked in red at the top on the left hand side, and the internet connectivity towards the top right. This Windows box is on the left hand side, 192.168.101.10, and the first thing that we'll look at is its connectivity to every other device within site A. So I just brought back up the screen. As you can see, that's what this device is on the map. What I'm going to do is I'm going to telnet to this device, SSH to this device, and once I've connected to that device, I'm going to do some basic continuity testing from that device to show you that it can reach other devices. I'm trying to log on now. Unfortunately, it's going to be really slow because I've got all the machines running at the moment. I'm sort of in 2 minds whether to start shutting them off. So let me put the password in. Okay, so now what I'm going to do is I'm going to connect. So I'm now on that Linux device, that second device there now, and I'm going to ping across to a device in the other network, which is I'm on site 1, so I'm going to be pinging now to site 2. Like I said, the response is pretty slow. It's, these machines are not, these VM servers are not fast, so you're going to have to bear with me. So I'm trying this ping. Oh, there you go. It's now come through. So now that ping is successful. Now I'm reaching from site 1 to site 2 using ping. And now I'm going to jump on the box I just pinged, which was the Linux box in site 2. And again, it might be a little bit slower. There might be a little bit of a better performance on this one because it's a smaller footprint box. So just logging on now. So these are the devices that I'm going to be pinging to. So I'm now on the other side, on the right hand side, pinging to the devices on the left hand side. So I'll ping the Linux box first. So that will be pinging the bottom box. And as you can see, it's successful. So now I'm going to go and ping the Windows box, which is the one on the top there, .10. And I got a response, no problem at all. And just to show you that I can, I'm going to ping the customer's intranet server now. So just to let you see that it can get to the F5 shared network. So that's successful. And just because I've got all the machines running at the moment, I might turn some of them off. I'll just show you that the cross-site rules are working by trying to from here to try and ping one of the other customer devices. As you can see, I'm trying to ping a customer B device, and it's not successful in site 1. So I'm going to try and ping a customer C device in site 1, and again it's not successful. And if we go over to the other side, if we go on to site 2, which this box is in, and we try and ping that Linux one on site B, in site 2, sorry, you'll see that that's not going to work either. Now, just going back to the part where the policy specification is that the management network can reach the Linux box in customer A on site 1. So I'm just going to log into that box now, and I'm on the customer network now, so I'm going directly from the management network. So bearing in mind this is a little bit slow, so I'll jump onto the SRX to show you the actual. I cannot be able to get to it from the SRX, so I'm going to jump onto the F5 SRX on the core. There you go, I just got a password up now for the other one, so let's log in here. And I'll just jump back on here and log in. So I am now from the management network, I am on this box. So I'll just get out and I will try to go to the other box in site 2, which I shouldn't be able to get to because that policy does not define my access to that second box. So just to do a little bit of continuity testing on the F5 SRX, note that I'm actually going to be through the customer A VRF. So even though I can reach all the customers from the SRX, that is from the F5 shared network, not from the customer A VRF. So you can see I can reach the customer A sites, but I can't reach any of the other ones through the customer A VRF, which is what we're expecting to have happen. So I'm just doing some initial continuity testing on the SRX. I'm just using IP addresses here. It's a little bit quicker to type on the SRX than the fully qualified domain names. And I'm now going to be trying to attempt to now log on to the customer A Linux box in site 1, which I should not be able to do because the policy defines that the management can reach it only. So now I'm on the F5 SRX. You notice it's just the other management's just timed out on the other one that I was trying to get to on the management box. So the management box can indeed only reach the site 1 customer A. I'll just put the IP address in instead of the protocol domain because it's quicker. But as you can see, in a minute it will come up and it will I should be able to just log on. So, but the SRX can't because the SRX has not been allowed to. So as you can see, it's not going to happen. So so basically, management. There you go. Management. The password's just come up for the management one. So yeah, so it's the management's able to get to that particular device, but nothing else at the core will be able to. Now I'm going to jump onto customer A Windows box at site 1, and I'm going to log on to the intranet site for customer A. So let's put in the details. So I'm going to intranet.customera.com, and what I'm expecting to see once I log on is when I go to the URL, it's a logon page because it's going to ask me to present my credentials because I'm a customer A. Like when I went in as from the management, I didn't need credentials, but I will need credentials when I log in this way from this site. So just going to log through. It's okay. Just going to look at the certificate. So as you can see, I'm logged on. So the certificate is it's for customer A, signed by the intermediate CA. So I'm going to log on with my Radius credentials because the F5 is authenticating all the users through Radius. So I'm going straight through, as you can see. So that's all what I'm expecting to see. Now I'm going to try and access the public B intranet site, the private site for customer B, from this customer A Windows server. So when I try to do this, the policy on the F5 will see me coming in and I'm not a customer B user, so it's going to automatically redirect me to the customer B public website. On all the public websites, and credentials are not required, so I should be just allowed to go straight through to the public website. It's a little slow, but hopefully you should see it goes directly to public B's public website, which it does. And that's exactly what I'm expecting it to do. And just for completeness, we'll get customer A to attempt to try to get to the customer C intranet site, but once again the F5 policy should just redirect it to customer B's public website. So I'll just try that now. And there you go. So it's been redirected to customer C's public website, which is exactly what I was expecting it to do. Okay, so now I'm going to see if I can get out to the internet. Okay, so I'll go to Google. When I tried this before, prior to this presentation, it was pretty slow, so I'm not sure what the response is going to be like. So let's log through. Don't forget, I've still got all the machines still running, so hopefully it might respond a bit better. That's looking promising. So yeah, so I'll go to today's news, I suppose. I can't get today's news, so let me just put that in. See where we are. That was pretty quick. Okay, so this is looking good. So just log on through and I'll get today's news up. I'm not so sure. It's not coming as quick as Google, obviously. So let me see if I can check with I'll just open up a SSH session and see if I can get to the internet, see if it's because of the LAN speed. So yeah, it's a bit slow. It's slow bringing up okay, it's coming up. Yeah, it's looking pretty slow. So I'm gonna see if I can get to the intranet. Now it's actually it's running really slowly, so it's not looking that hot at the moment. Let's see. Yeah, I might stop this actually because it looks as if it's going to be. I might try and shut down some. Okay, I might try and shut down some machines. That's probably okay. Oh, there you go. Yeah. Okay, so the news is coming. It's really slow. It's obviously because of because I've got all the machines running. So to do the next use case, I might actually shut down a few of the machines that I don't need. Well, as you can see, I've got all the machines running, and that's the reason why my sessions are so sluggish, because they're nearly all on. So I'm going to have to start shutting a few of them down. So I'm going to shut a few down before I start the next session. So start off on customer B by just going out to the internet. So this is a resource I use quite a lot. If you're into building web pages and need to know tips and techniques, this is an excellent resource to go to. I use it not all the time, but whenever I get into any problems with building web pages, is an excellent place to go. So as you can see, I can get a WebMonkey, no problem at all. So I'll just open up another window and think. Okay, let's go to Cisco. So Cisco website is good as any. So we'll go to cisco.com. There you go. So so it's it's getting out to the internet. Okay, a little faster now because I've shut some of the resources down, which is a little bit better. So if we can just quickly go through, I've left the customer site still on, so I can do the continuity testing. So if I quickly go from customer B, and we just quickly try and go to other customer sites that you see, we won't be able to get to them. So if I pick the customer C Linux box down the bottom there, if I try and ping that, you can see that I'm not going to be able to get to it, which is what I was expecting. Go to the other one, so 15, can't get to that one, so we try the other sites there as well. So again, yep, can't get to them. So pretty much everything that we try to do to get to any of the other sites, we still have that, obviously, the filtering. Like I said before, you still go through to the core, but we're filtering it out at source. So there's no way we can get through it. Customer C is a different scenario to all the others. The customer C has recently acquired a rival company and has asked the service provider to connect that company in via Site 2. This company is fully untrusted as it's yet to be integrated into the customer C business model. So it will not be able to communicate with any other customer C entities either at the F5 site or at Site 1 with any other protocols except ping, because it's required for testing purposes. However, users at Site 1, the customer C Site 1, will be able to communicate with the new customer on the protocols such as HTTP, HTTPS, RDP and SSH. However, during the transition period, the customers at Site 2 will still be able to get access to internet and the intranet to continue their own business while the transition is taking place. So here's the topology diagram for customer C. The workstations in red have the full access, and the ones in purple are the new customer that's got restricted access. So that's what it looks like. So we're going to go on now and do some connectivity testing. I've just quickly jumped onto the management network and actually did some continuity testing, some pings through to the all the different devices at customer C. If you can remember, I said that there was a site at customer A and a site at customer B that had management devices, but there are no customer C devices that the management should be able to get to, and this is what I'm testing for now. I'm testing to see if I can reach any of the devices on the management network, which I should fail to be able to connect to any of them. So I'm just going through them now. I can ping them, but I should not be able to connect to any of them. And so far I haven't been able to connect. I'll just try a couple more. So none of the devices so far I'm able to connect to. last one. So they're all going to time out. So effectively, there is no access. So that's the management side. Now I'm going to jump on to the. This is a box that's in the untrusted. So it's at the customer site, which is untrusted, the new customer. So I'm jumping on this box now, and I'm going to see if I can ping. So this is the box that I'm on, so it's one of the purple ones down there, the Windows box. So basically what I'm going to do is I'm going to go and ping across to site 1. So just so you can see them there. So I'm going to ping to site 1. So I'm going to start by trying to ping the Linux box. And these are the IP addresses because it's quicker than just putting the customer names in. So as you can see, I can ping, no problem at all. I'll go and ping the other one. And I can ping that one as well. So now what I'm going to try and do is I'm going to try and SSH to them. So this will not be able to do because I'm not allowed. I'm only allowed to ping. So I'm trying now. That's not succeeding. So I'm going to close that. And I'm going to go and try the other one. It's the second box in the site 1. And I'm expecting to have the same result. No response. Okay, so now I'm going to go and ping the box in my own site, which is immediately disconnected. So yeah, so that's continuity from there. I knew that was going to happen, so that's all that was expected. Okay, now I'm going to go to the site 1 now. So I'm going to log on to one of the Linux boxes in site 1 and run the same tests as I've done from site 1 to site 2 as I did from site 2 to site 1. So I'm just going to log on now. Okay. Okay, that's not going to work. So don't forget that management can't get to any of these devices. So I have to go through the management network to get to this device. Do you remember there's only 2 devices attached on the MPLS side that I can reach. So I'm going to logging in now via the management interface because don't forget this is dual home, and I'm going to run communications across from there. I just failed to get onto .20, but I just realised that .20 is a Windows box, so I can't SSH to a Windows box. I can RDP but not SSH. So I'm going onto the Linux box. So this is going to the Linux box on the untrusted network from the Linux box on the trusted network. So I'm just logging on now, so I can get to the Linux box. And there you go. So I'm on. So I am on the Linux box on the untrusted network from the trusted network. So so you can see if I jump on the site 2 and I do the same SSH session to that same site, to that same Linux box. I can do it from here because they're the same company. So I'm on the untrusted customer Windows box, and I am going to the untrusted customer Linux box. So I will be able to communicate with this box to this same box. And as you can see, this is the same box as the one I'm already on, connected on from site 1. So just logging it in so you can see it's the same. So you can see that I am on the same box. See, I'm on the same box. So I'm able to get to it from there. So I'm going to log out of that now. Like I said before, I tried to get to .10 on SSH, but obviously it's the Windows server, so I need to run it via RDP. So what I'm going to do now is I'm going to log in to this Windows box behind me using the Linux version of RDP. So let's log on now and see what we get. Okay, I haven't got X running, so I have to log out and I log it on as an X client. So give me a second and I'll just run it up again. Okay, and I'll run that same command again. I've got a password now, so I'll just log in and I'll get an RDP session to that box. Hopefully, there you go. So I'm now RDPing in, and I'm now, as you can see, I've picked up that session. It was already running in the background. So see, it's looking me out on this one. So, yep. So it all works good. So I'm able to get to the untrusted devices from the trusted network, but I'm not able to do anything from the untrusted network out back to the trusted network, which is exactly what was required. As with the other customers, they can get to the internet, so it's customer C. So we're on the customer C untrusted, so we're just going onto the internet from there. So as you can see, they're going to be able to get to the internet, which is obviously a requirement. And then what we need to do then is to go to the other customer, the intranet sites that we need to get to as well. So if we go to the other intranet sites, so intranet A, so go to intranet A. Like I said, the policy, F5 policy, will actually redirect this customer to the public site. So I got to A's public site, as you can see. More easy to see than here. A second, I'll take that. And this is a customer A public website. Let's move it around a little bit so you can see. So that's public A website. And now we go ahead and do the same thing with the customer B intranet. And obviously that should take you to the customer B public website, which it does. So no surprises there. So now if I go to the intranet C website, I should get to the intranet now via the credentials, which I can. So I'm going to go in via MICF again. They're all the same usernames. I've just set them all the same. So then I get on here, and that will take me to the intranet website. But for some reason, another reason. Yeah, some of the machines that I've turned off. One of the machines I turned off was actually the inner radius box, so I won't be able to get in because it uses radius for authentication. So I won't be able to get in via the intranet site. But I will be able to get to the public site, of course, because that hasn't got authentication on it at all. So I'll be able to go straight there. So as you see, I'm able to get to the public one. Oh no! What's that? I will have to check that. There you go. I was about to say, I thought it was a bit weird. So there's the public website. What I'll have to do when I go to the next stage, I will turn radius back on because we're going to need it to be able to get in remotely from the internet. So yeah, so there we go. So this is, I just thought I'd show you the ISP. The ISP's got a couple of websites. It's got a private one and a public one. I'm just going in, so I'm just going to go in from the untrusted network. So the untrusted network in customer C is able to get to both these websites. So there you go. So this is, it's not showing everything. There's a fancy background in the background, but it's quite a big GIF, so it probably won't load through here. So I'll just go show you the other site, which is the this one here. And again, it's fairly similar. No, actually, it's the same. Actually, I might have the wrong one. Anyway, so basically, you'll be able to get to the ISP portal sort of through the same sort of methods as you get to the other customer sites. Okay, so this is the last part of the presentation, which is on the secure remote access. I'm just going to go into the F5 just to show you it. It's basically it's configured as a VIP, so I have to go into the F5 itself and configure a new virtual server, just like basically a web server. It requires a number of. It's obviously slightly different in the way it's configured, but from the front end, it looks just like a VIP. So I'm just jumping onto the VIPs now. I'm just going to go down to the bottom where the, as you can see, all the devices are up. They're all green. So I'm just going to go down to the bits that are relevant to the remote access, which are these ones down at the bottom. And I've just noticed that my radius server's down, so I'm going to have to actually do that one as well. So I'm looking at the MPLS VIP, and in order to be able to connect to this, I'm going to have to disconnect myself from the internal network and connect externally, because I need to be coming in from the outside. So I'm connecting across to my outside network. So now I'm not going to be able to connect because I've immediately moved myself from the inside to the outside. So now I'm going to connect to the VIP, which is on the outside network. So I'm just going to put it in by its IP address because I haven't set up a host name for it. So just going to connect through now. Now you can see it's presenting me with a login screen where I can enter my credentials. So I'll just do that and just put it through, and I'm waiting. Probably the radius server. I've got another machine. I've already started the radius server up on the other machine, but I suspect it's not come up yet. So what I'll do, I think I'll probably go back and check the F5. So I'm just going to connect back onto the other network so that I can get back onto the F5 and see what's going on. Pretty sure it's just the radius taking its time to fire up. Yeah, come on. I don't know. So I've got connection. Okay, radius is still booting up, so I'll just wait for that, just refresh it and go back to it. And radius is up now, so I should be able to get through now. So I'm going to try and go back to the other network and see if I can get back onto the landing page. So now I'm going to go back to the outside network and try and reconnect in again. Should work now that radius is running. So yep, so I'll go through and re-establish the session and put in my credentials, password. So hopefully this should be, this should now get me the web top. So I'll be presented with a web top now, hopefully. And there's only one item on that web top. There can be multiple items. That could be RDP, an RDP session inside or something like that. I've only got secure remote tunnel access, so I'm just going to get it established, and hopefully we should be able to get a tunnel through with some traffic. Yeah, there we go. So I've already got tunnel, so I'm just going to run up a new SSH session. And I haven't got any routing or anything running on this. I've just set it up basically so I can connect into the F5 shared network, so I haven't done anything fantastic. But so I should be able to get to some of the items on the F5 network. So the SRX, for instance, I should be able to get to. So I'm just going to try and log on to that now. Yep, I've got a password, so I'll hit it. So yeah, there I am. I'm on the F5 SRX, which is effectively on the inside network coming in from the outside. So it's been successful. I mean, I would normally use a client for this, but I'm just running it out quick because this has already been a very long presentation. I'm sure you're getting tired as well as me. So there you go. So that's basically it, and I'll just run through a summary in a moment. The aim of this video was to showcase the skill sets that I possess, particularly with networks, network security and systems. and illustrate my ability to think laterally in the approach to problem solving. Specifically in my competence with operating systems, in particular Unix. In addition, to illustrate my ability to create large lab environments with relatively small amounts of hardware.